dot, orbiting an average star, on the inner rim of a spiral galaxy that itself is one of billions. And despite all the chaos out there, we've built stories. Empires. Dreams. We've launched telescopes to watch the stars that might one day destroy us. That's human nature, to gaze into the abyss, and still reach for the light. Our survival isn't guaranteed. But our curiosity is unshakable. So when you look up at the stars tonight, remember, they're not just twinkling lights in the sky. They're warnings. Clues. Messages from the cosmos, written in the language of gravity and radiation and time. And we're listening. And then, there's the silence. Not the absence of sound, but the cosmic silence. The eerie emptiness that stretches across billions of light years. The Fermi paradox asks us a question we don't like to answer: where is everybody? If life is common, intelligent civilizations should be everywhere. But we hear nothing. What if that silence isn't empty? Some scientists have theorized about cosmic filters, deadly events or natural laws that prevent civilizations from reaching maturity. What if every civilization that reaches a certain technological level triggers its own destruction? A cosmic firewall, built into the universe itself. Maybe it's artificial. Maybe it's the universe pruning its own branches. If we've passed that filter, we might be one of the lucky ones. But if it's still ahead, then our most dangerous threat isn't out there, it's inside us. But the universe doesn't need us to sabotage ourselves. It has its own celestial artillery, like quark stars, a theoretical class of superdense objects. Denser than neutron stars, they compress matter into a strange state that could destabilize nearby systems. If one of these rare stars were to collapse or shift phase, the energy release could send a shockwave through the galaxy. Not just light, not just gravity, but a fundamental rewriting of baryonic matter. Earth could be converted into something entirely alien, something unrecognizable. Still spherical. Still massive. But no longer a world. No longer alive. And what about planetary orbital resonance? We take comfort in the solar system's balance. The planets orbit with serene precision, year after year. But all of it, rests on fragile gravitational threads. Over long enough time scales, small nudges, from a passing star, a shift in Jupiter's orbit, or even the collective motion of the galaxy, could unravel that harmony. Mercury could spiral inward. Mars might drift out. And Earth could be thrown into the sun. Or flung into the cold black. Our home is stable not because it must be, but because it happens to be. For now. Even the tools we use to understand the universe could turn against us. Take high-energy particle collisions. Our particle accelerators smash atoms together at near-light speeds, probing the very fabric of space. But some have wondered, what if, one day, we cross a line? What if a collision creates a stable black hole? Not a wild, massive one that eats planets, but a small, quiet, hungry one. One that begins to sink into the Earth's core. It wouldn't explode. It wouldn't roar. It would simply consume. Slowly. Irreversibly. The surface would remain still, until, one day, it caves in on nothing. Speculative? Yes. But in a universe where black holes exist, can we say it's impossible? And then there are time-based instabilities. We think of time as constant, but in extreme gravity, or in quantum theory, it becomes malleable. What if a distant gravitational event created a temporal shear? A rift in the uniform flow of time that begins to distort causality on a planetary scale? Events happening out of sequence. Chemical bonds failing. The laws of physics fluctuating. Imagine waking up, before you were born. Imagine seeing the sun rise, but never set. Imagine your atoms forgetting what it means to be. That's not destruction in the physical sense. It's ontological annihilation, a dissolution of meaning itself. The scariest part? We might never know it happened. So many of these threats operate on scales beyond human perception. They don't announce themselves. They don't pause for comment. They act according to rules written in the deepest layers of spacetime, layers we've only begun to scratch. And still, here we are, building telescopes, writing equations, sending out signals into the void. Not because we think we're safe, but because we know we're not. Because the act of looking is its own kind of defiance. Earth is a miracle of balance. And miracles, by definition, don't last forever. And yet, knowing all this, knowing the universe is filled with chaos and indifference, that our planet is more fragile than we like to believe, we do not look away. We build. We explore. We wonder. Because that is what makes us human. Not just our biology. Not just our intelligence. But our capacity to face the void, and still reach toward it. We send out probes. We dream of Mars. We decode the radiation of ancient stars. We dare to ask the biggest questions, even as we spin through the galaxy on a cosmic speck of dust, surrounded by forces that could erase us in an instant. But we are not small because we are vulnerable. We are vast because we are aware. We are the universe, thinking about itself. Asking where it came from. What it's made of. And how long it will last. And maybe, just maybe, that awareness, that flicker of curiosity in the dark, is the very thing the universe has been waiting for. So the next time you look up, remember, the stars are ancient. The cosmos is dangerous. But consciousness, your consciousness, is rare. Precious. And powerful. That, perhaps, is our greatest defense. And our greatest gift. Top 7 stars that shouldn't exist. The universe, in all its vastness, operates with rules. Gravity, fusion, entropy, laws that stretch across billions of light years, written into the very code of reality. And yet, every so often, we find something that breaks those rules. Something that shouldn't exist. Something that laughs in the face of physics and says, try explaining this. Today, we're not talking about ordinary stars. Not your run-of-the-mill balls of plasma burning hydrogen like cosmic fireplaces. No. We're talking about the rebels. The freaks. The ones that make scientists scratch their heads and question everything we thought we knew about how the cosmos works. Let's begin with one of the strangest offenders, HD 140283, also known as the Methuselah star. Located just 190 light-years from Earth, it looks pretty ordinary. But when astronomers calculated its age, their jaws hit the floor. This star appears to be 14.5 billion years old. That's older than the universe itself. You heard that right, older than the Big Bang, which happened about 13.8 billion years ago. How is that possible? Now, of course, the universe didn't break its own clock. More likely, it means that something in our models is off, maybe the measurements, maybe the assumptions, maybe the star formed from primordial material left over from the Big Bang in a way we don't yet understand. But still, imagine finding a passport that says someone was born before time itself. That's HD 140283. It sits there, defying logic, challenging cosmology, and looking completely unbothered. And then there's our 136A1, the heavyweight champion of the cosmos. Located in the Tarantula Nebula, inside the Large Magellanic Cloud, this star is a monster. It's more than 250 times the mass of the Sun, and it shines nearly 9 million times brighter. According to our best theories, stars this big shouldn't exist. The forces trying to blow it apart should overpower the gravity holding it together. And yet, there it is. A beast of burning gas so luminous, it could strip the atmospheres off planets from light years away. Its life will be short, maybe just a few million years, but it will end in a supernova so powerful, it could leave behind a black hole big enough to swallow a star cluster. Our 136A1 isn't just a star. It's a cosmic furnace pushed to the absolute edge of what physics can handle. Now let's travel to the opposite extreme, to a star that's not big, but dense beyond reason, PSR J1748-2446 AB. This one doesn't shine brightly. It doesn't blaze across space like a quasar. It just spins. And spins. And spins. This is a pulsar, the collapsed core of a dead star, a neutron star, and it's rotating 716 times per second. That's faster than a kitchen blender. Faster than a helicopter blade. Faster than anything that massive should be able to spin without tearing itself apart. It completes one full rotation in just 1.4 milliseconds. Try to picture it. A city-sized ball of ultra-dense matter, heavier than the sun, rotating hundreds of times per second, emitting radio pulses with the precision of an atomic clock. If it spun just a bit faster, the centrifugal force would overcome gravity, and it would explode outward. But somehow, it doesn't. Somehow, it holds. And it shouldn't. Then there's HV 2112, a star that might contain elements that don't belong inside stars. This strange giant, located in the small Magellanic Cloud, shows spectral lines of molybdenum, rubidium, and even lithium, elements that typically form in completely different environments. For years, scientists didn't know how to classify it. It didn't fit. It looked like a red supergiant, but with chemical fingerprints that didn't match anything we've seen before. One theory. HV 2112 might be the first example of a Thorne-Zitko object, a theoretical star formed when a neutron star merges into the core of a red supergiant. A star within a star. A cosmic Russian nesting doll made of fire and nuclear madness. We're still not 100% sure. But if that's what it is, it shouldn't exist. It's like finding a black hole inside a candle. Let's turn now to SMSS J03130036-6708339.3, don't worry, we'll just call it J03. This ancient relic, floating in the halo of the Milky Way, may be one of the first stars ever born after the Big Bang. But here's the kicker, it has almost no iron in its composition. That might sound trivial, but it's huge. You see, stars are born from the remains of older stars. Every time a star dies, it enriches the cosmos with heavier elements. So the next generation should contain more metals. But J03 has almost nothing but hydrogen and helium, just a whisper of the heavier stuff. It suggests this star formed in a universe barely out of the womb, before supernovae had a chance to seed the cosmos. It's a ghost. A time traveler. A living fossil of the ancient universe, drifting quietly through space, telling us stories older than Earth itself. And the fact that it's still burning, still shining after all this time, that breaks everything we thought we knew about stellar lifespans. But perhaps no star breaks our brains more than KIC 846-2852, also known as Tabby's star. Located about 1,470 light-years away, Tabby's star made headlines when astronomers noticed it dimming in bizarre, unpredictable patterns. Not once. Not twice. But dozens of times, by up to 20% of its total brightness. That's not just a planet passing in front. That's something else. No natural explanation quite fits. Dust clouds? Maybe. Swarms of comets? Unlikely. Colliding moons? The wildest theory, and the one that captured public imagination, was this, a megastructure. A Dyson swarm. An alien civilization building a star-sized solar power station. Is it aliens? Probably not. Is it weird? Absolutely. Tabby's star doesn't behave like any other star we've ever observed. And the fact that we still don't have a solid explanation, that's both terrifying and exhilarating. Still think we've seen it all. The universe is just getting started. Let's shift gears and meet a star so cold, it challenges our very definition of what a star even is, WISE 0855-0714. Technically, it's a brown dwarf, the awkward middle child between stars and planets. Too big to be a planet, too small to sustain hydrogen fusion like a proper star. But what makes WISE 0855 so absurd is its temperature. This object has a surface temperature of around -13 degrees Celsius 8 degrees Fahrenheit. That's colder than your freezer. That's cold enough for clouds of water and ammonia to form in its atmosphere, clouds made of ice, not plasma. A star with clouds. A star that could, in theory, snow. And it's only 7 light-years away. In our backyard. Barely glowing. Barely radiating. But somehow massive enough to be called a substellar object. It shouldn't exist by standard models. But there it is, floating silently in the interstellar dark, a ghost of a failed star, chilling in every sense of the word. Now let's flip that idea on its head. Enter Mira A and Mira B, a binary system that looks ordinary at first glance. Mira A is a pulsating red giant, and Mira B, well, that's where things get spicy. Mira B is likely a white dwarf, a remnant core of a dead star. But what's bizarre is how Mira A sheds its outer layers, and Mira B sucks them up, forming a disk of material around itself. It's stellar cannibalism. A cosmic love story turned horror movie. This feeding frenzy has gone on for centuries, possibly longer. It's like watching the end of a star's life become fuel for another, a bizarre recycling program of fusion and decay. And what's more baffling is that Mira A is racing through the galaxy, leaving behind a trail of glowing gas stretching 13 light-years long. It's like a comet tail, except the comet is a star. Nothing in our textbooks said this should happen. Nothing said stars should leave behind glowing stellar contrails across the galaxy. But Mira does. Now let's talk about a star that is, quite literally, made of diamonds. Yes, really. Meet PSR J2222-0137. It's a white dwarf. But not just any white dwarf, it's an ultramassive one, composed mostly of carbon and oxygen, compressed so tightly that much of it has crystallized. That's right. This dead star, once larger than our Sun, has cooled and solidified into a crystal sphere the size of Earth. A diamond star. A literal cosmic gem, shining faintly in the void. In fact, astronomers believe some white dwarfs in our galaxy have been cooling for so long, they've completely crystallized inside. Imagine holding a diamond, billions of carats wide, drifting through space. It's one of the most poetic contradictions in nature, a thing born of death, collapsing into beauty. But it also raises questions. How common is this? How many jewel stars are out there, twinkling invisibly in the dark? And could these objects represent a final stage of matter, stars that have turned into silent monuments of time? Now, we can't talk about impossible stars without visiting one of the strangest in the entire catalog, 2MASS J0523-1403. It is the smallest known star capable of fusion. Just 8.6% the mass of the Sun, it barely squeaks past the threshold needed to sustain hydrogen fusion in its core. Any smaller, and it wouldn't be a star at all, just another brown dwarf. Its radius is only about 1/10 that of the Sun, and yet it manages to burn. Faintly. Quietly. Endlessly. It will likely outlive every other star in the galaxy, shining dimly for trillions of years. Why is it so weird? Because it's the lower boundary of stellar possibility. The absolute minimum mass needed to spark nuclear fire. The edge of stardom. And yet it exists, living proof that the line between planet and star is not a line at all, but a shimmering, mysterious gray zone. And finally, let's visit RZ Piscium, a star that's eating its own planets. This young, volatile star shows strange dimming patterns, like Tabby's star, but with a twist. Astronomers believe it's surrounded by a dense disk of gas and dust, not from the remnants of its birth, but from disrupted planetary material. That's right. RZ Piscium is likely tearing apart its own planets, shattering them through tidal forces, heating the fragments, and pulling them into its blazing atmosphere. Imagine entire worlds being pulled to pieces, swallowed by their parent star in a spiral of fiery doom. It's not just a star. It's a destroyer of worlds. A cosmic executioner. And it shouldn't exist. Because planetary systems are supposed to stabilize over time. Orbits settle. Gravity calms. But here, everything is still violent. chaotic, apocalyptic. It's a glimpse into the adolescence of stars, and a warning, not every system ends in peace. The more we explore the cosmos, the more we realize, the universe doesn't care about what should be. We make models. We draw charts. We calculate boundaries and build equations that describe how stars are born, how they live, and how they die. But again and again, the stars surprise us. They refuse to fit into our neat little boxes. From ancient stars that seem to predate the universe, to massive giants that shouldn't be able to hold themselves together, from frozen failures that pretend to be stars, to diamonds adrift in the dark, each of them tells the same story: we don't know everything. We like to believe we've got this universe mostly figured out, gravity here, fusion there, a pinch of dark matter to spice things up. But then the cosmos throws us a curveball. A star that spins too fast. A system that eats its own planets. A fossil of the early universe still burning billions of years later. And what do? We investigate. We revise. We learn. Because that's what science is, not a list of answers, but a process of curiosity. A willingness to be humbled by the impossible. These stars, the misfits, the monsters, the mysteries, they remind us that the universe is still wild. Still strange. Still full of secrets waiting to be uncovered. And isn't that what makes it all so beautiful? Because beyond the numbers, beyond the theories, beyond the telescopes and satellites and simulations, there's wonder. That childlike sense of awe when you realize that somewhere out there, in the cold black silence of space, a diamond the size of Earth is spinning, a zombie star is pulsing like a beacon, and a newborn sun is tearing its own planets apart. These aren't just astrophysical curiosities. They are poetry. They are defiance. They are proof that the universe is more imaginative than we are. And while these stars may not make sense on paper, they exist. They burn. They whisper, across light years of emptiness, you have no idea what's really out here. And that's why we keep looking up.
Top 5 Deadliest Objects in the Universe. They say space is beautiful. That it's awe-inspiring, majestic, a place of wonder. And sure, it is. But let's not kid ourselves. The universe is also terrifying. It's ruthless. It's ancient. And it's armed to the teeth with things so dangerous, so mind-meltingly hostile to life, they make the most brutal places on Earth look like a warm bubble bath. We're not talking about bad weather or no oxygen. We're talking about death on a scale so absolute, so final, that your atoms wouldn't even have time to scream. We're going to take a journey, a wild ride through the cosmic underworld. No metaphors, no sugarcoating. Just raw, brutal truth about the deadliest things the universe has ever coughed up. Let's start with the neutron star. Sounds harmless, right? Like it could be your next sci-fi action figure. But don't let the name fool you. These things are the corpses of once mighty stars. Massive stars, several times heavier than our sun, live fast and die young. And when they run out of nuclear fuel, gravity takes over. It's a cosmic implosion. The outer layers explode outward in a supernova, but the core. Oh, the core collapses. It gets crushed down to something so dense, it's almost incomprehensible. The entire mass of a sun-sized star is compacted into a sphere just a dozen miles across. You want numbers? Try this. 1 teaspoon of neutron star material would weigh as much as Mount Everest. That's not poetic exaggeration, that's raw physics. The matter inside is so tightly packed, the nuclei of atoms are literally fused together, forming a sea of neutrons. It's not even solid in the way we understand solids. It's a quantum soup, where the laws of physics start to bend like rubber. And then there's the magnetism. Neutron stars don't just sit there. Some of them spin hundreds of times per second, unleashing pulses of radiation like a strobe light from hell. These are pulsars, cosmic lighthouses blasting gamma rays across the galaxy. Others are magnetars, the most magnetic objects in the universe. Their magnetic fields are 1,000 trillion times stronger than Earth's. That's strong enough to tear electrons off atoms from thousands of kilometers away. Strong enough to mess with your brain chemistry. If you somehow found yourself near one, which, let's be honest, is already a death sentence, your molecules would be rearranged before you could blink. But neutron stars aren't just deadly. They're elegant. Perfect. The universe distilled into a spinning jewel of doom. And yet, even they aren't the worst. Because somewhere out there, in the deep, silent dark, is the quasar. Now, quasar might sound like a high-tech gadget or a sci-fi villain, but make no mistake, these are the cosmic flamethrowers of deep time. The hearts of ancient galaxies. Supermassive black holes, millions or even billions of times more massive than our sun, gorging themselves on gas, dust, stars, anything foolish enough to wander too close. As this material spirals inward, it heats up. Not just a little. It reaches temperatures of millions of degrees. It glows with blinding energy. It emits radiation across the entire electromagnetic spectrum, radio